Welcome to myprojectbazaar.com. Our product title is a high throughput energy efficient implementation of successive cancellation decoder for polar codes using combinational logics. Now we are going to discuss about our product abstract. So our product main objective is high throughput energy efficient successive cancellation decoder architecture for polar codes based on combinational logics. So our proposed combinational architecture operates at relatively low clock frequencies, national architecture operations that in the sequence compared to the sequence circuits, but that take advantages of the high degree of parallelism inherent in such architecture to provide a favorable trade-off between the throughput and energy efficiency at the short to medium block length. At longer block length of the base papers, the hybrid logic successive cancellation decoders that combines the low complexity nature and sequential logic decoders. Performance characteristics of ASIC and FPGA are presented with the detailed power consumptions analysis for the combinational decoders. Polar codes were proposed and the low complexity channel coding method can be probably achieved for the capability for the binary input systematics discrete the memoryless channels. Apart from the intensive theoretical interest of the subject, polar codes have attracted the attention of the potential applications. And then the basic decoding algorithm for the polar codes in the successive cancellation decoding algorithm with the non-iterative sequential algorithms complexities. And then the second algorithm approach to break the throughput exploiting the polar codes are the generalized continued codes, and then the right each to be the polar codes and the right each and the decomposed. The present work is motivated by the desire to obtain high throughput successive cancellation decoders with the low power consumption which the concern the literatures. The desired the properties of the attain the complexity combinational decoders architecture, which is the possible feed forward structures in the successive cancellation algorithm. Combination decoders operate at low clock frequency. Now we are going to see our product flow diagram. So this is our flow. First initially we are giving the two 16 input data, and then the 16-bit data is going to the parallel based input bit logic functions. As fully parallel architecture will cause a high hardware implementation complexity problems with the memory sharing. The partial parallel architecture limited to the memory units of the high throughput application. The temporary results should be in the register rather than the memories at the multiplexers to control the connecting wires. And then we are going to the parallel encoding architectures. This process trade off the between the hardware cost and the throughput is achieved by register based on the parallel architecture. And then the encoding process, the polar code process, is a new way of data encodes and decodes architecture. This methodology is mainly used to the error correction process. We design the polar encoder architecture based on the parallel from to reduce the hardware complexity level. Polar codes minimize the logical gate count level and improve the encode processing time on. And finally, the encoding the data bits result will be the encoding process consists of 4-stage process, and each 4-stage require the 4-bit input for the encoding process. First stage 2 consists of the XOR gate functions, and the second stage is to perform the invested bit XOR gate functions. The third and fourth stage process consists of the mux with resist element of the XOR based logic operation levels. And then we are going to the logic, the decoding architecture. In this process the decoding allocation of the mux functions. The third and fourth stage process is mainly focused by mux and a register instructions logically block. The T register is used to store the update data accumulated every clock cycles. The four multiplexers serve as data latches to keep on the output without changes during the encoding iterations. And then the process, the performance analysis. The memory sharing the partial parallel architecture can achieve a good place on the throughput and hardware cost in the large range. The calculations of the critical path done, which is the same for the top and bottom leads high clock frequency. Polar encoding is a very suitable for the LTPC codes because the number of incoming message to each processing units the uniform across the entire clock cycles. Now we are going to discuss about our product running processor. So our product is polar codes. Polar codes means how to the data encoding and the decoding the architecture, the structures of how to we are using the mux. So whatever the process is I have to encoding the and decoding the process in coding in there. We are using the lot of signals at here. See, and then now I'm going to running this process here simulation, and then simulate the right double click the simulate behavior model. The IC model is automatically open, and we have to give the input, and we get the show the output process. So now we are I'm giving it a clock pulse. So here I give the force clock leading edge values 0 and trailing edge values 1 and periods is 1000 nanosecond. So this is output, and reset also giving the force constant is 0 and signal also giving the 0. First we are giving the constant value 0. So now I'm going to running the process, and then we are going to go to the values, reset values 1. I'm just running. Now I'm going to the processes, so signals give the 1 and then running, and then I'm going to constant value 0, so run it. So I'm just split the output values here. So we have separate the encode and decode and encode and how to we data encode encoding the process, how to we get the decode the process the data. So we have implement that the values, iteration values also, how to split it there. So this is polar codes encoding and data encoding and data decoding process. Now we are going to see the implementation process. Here I am going to implement, and then running this process synthetic XST. So right now also view the RTL schematic and also implement design also. Here detailed report is here, synthesis report. So now we are going to see the report also. So now I'm going to view the RTL schematic diagrams. This is encoding, add, create a schematic. So this is the encode and process. So it is in this process we have designed encoding and decoding process. This is our schematic diagram, and then we have to see the implementation report. So now a detailed report, we are going to see the synthesis report. So this is our synthesis report for polar codes. So this is a device utilization summaries. Select device. This is our number of slice registers 4, and the number of slice LUTs 22, and number of used as logic 22. This is, and then we have timing process is also 0.817 nanosecond. All timing displays nanoseconds. So this is our process result is output result some performance analysis.